Chapter 5, Color. Alright, so when I first got into digital painting, I had some very crude methods that I used to create images. I would do pencil sketches, and then I discovered Photoshop back in Photoshop 2, I think. It was a long time ago. And I would scan in pencil drawings, and one of the methods that I used was I would take the layer and I would put the layer into multiply mode, which would make all of the dark parts opaque, but all of the light white parts transparent. It's a quick way of saying it. And make a layer underneath, and then I would paint on the layer underneath. So I would go get a brush here and say, all right, I want this guy to be, get a bigger brush here. I could make him purple or whatever, but because I'm painting underneath, it's just kind of giving the general color. Now, the problem with this is that all of my paintings kind of looked muddy, and they looked like an image that had just kind of roughly been colorized, but not really a vibrant color. And thinking of color and light in the real world, it was just kind of tones. The problem with this kind of painting, let me show you a better example so I don't have to sit and paint this here the entire time. Alright, so I had a sketch here, put it in multiply mode, and this was something that I had done a long time ago. The problem with something like this is, it's not bad, but I'm thinking of color in a sense of value. Just, if something is light or dark. I'm taking a kind of yellow here, and it's a darker version of yellow and a lighter version of yellow. And the kind of tan color, it's lighter and darker. And the pencil sketches are just making things lighter and darker. It's only value, not thinking about what happens in the real world with color. So if I wanted to create something out of this, I could do that same painting method. But what if I wanted to create something more, along the lines of this? Not that this is a great painting or whatever. I do lighting in 3D most of my time, but kind of learn some new methods for colorizing. So let me take some time to talk about it. So the very first thing I want to talk about is color temperature. Okay, so if you were to go and study color temperature or color theory, you'd probably hear the terms, kind of degrees Kelvin, and how different degrees Kelvin are different kinds of light. From low light with a candle will get these certain colors of light, and then sunset and daylight and overcast sky and blue sky, and the different kind of tones of color in degrees Kelvin. I'm not really going to talk any more than I already have about this, because we need to think about it from a practical standpoint, not from a technical standpoint. So color temperature, let me describe it in this way. Let me switch over to Painter here real quick. Alright, so if I'm going to create something here I want to have something that looks like it's hot. Okay, so like a oven stove or something like that. I could say, well, things like a stove top could be red. So the hottest point will be bright red, and then it'll kind of just fade out there, and it's just value alone. The value of the red. Bright red and darker red. Kind of blends itself down. This method to me is, it's okay, but it's, not the greatest. Same with, I'll have something that is kind of cool here, the brightest spot, and then it kind of fades off. This will make sense in just a second. What if I start thinking in color temperature? So what happens in the real world when you have something that that actually gets brighter? Let's go back to Photoshop real quick and take a look at some photo examples, and then we'll go back to Painter and finish this up. So, all right, so here's some Christmas lights, and we can see kind of their brightness, and they're different colors. So let's do some color sampling here. All right, so if you notice let's start with this orange one. All right, so this actual color here is this kind of bright orange, and pay attention. So the color picker in Photoshop, you should be kind of knowledgeable of it, but if you aren't, this is saturation. So over here is more saturated, over here is less saturated, and the top has, its value. So very bright and very dark. So you can pick any one here for a color, right? So if I pick this, the darkest point on it is this bright orange. And then as it gets brighter and brighter, notice that the actual value isn't changing, just the color is changing. It's actually going more towards yellow, and right at the core it'll be white, pure white there. But it's going from this deep orangey red. Actually, there's some pretty strong red colors in here, and it just kind of goes gradually. It follows the whole color temperature thing, like the degrees Kelvin, from red to orange to yellow and up to white. All right, let's look at another one. All right, so this blue here, it's this deep. There's certain points in here. It's kind of bright, deep blue, and as it gets brighter, it goes more towards this aqua type color and then to white. So that follows the same idea of the dark blue kind of aqua color and then to white. All right, so this is the practical application of it. If you were going to paint something that looks like light, you might want to think about, color temperature. Right? So this is here's another example here. So we got, instead of just having, a bright yellow spot that kind of fades off to a gray yellow, you get something, you want to have this red light. It starts off kind of yellow, then orange, and then red. It's following that same kind of scale. Even over here, hot white, then to yellow, then to orange, then to a little bit more red and saturated as it falls off. Same with down here. When you look in the blues, you've got the same thing. Down in here, you've got this deep, saturated, almost purple blue, and then it fades up into a more standard blue, and then to more of an aqua blue and kind of closer to white. Here you get the nice mix of the blues and the oranges, so you get these purples that kind of interact too. But this is something that I don't think is talked about very often when creating artwork, but it exists. Looking at lights, look, here we have the same thing. And these are little lights that I have in my house. It goes from this kind of deeper saturated, almost red here, to orange, to yellow, and gets brighter and brighter until it's at white in these kind of cores. Let's look at a little bit more subtle example here. So these objects actually stay consistent in color. If you see a pool ball, the brightest point here, of course, is kind of a yellow, and then as it goes down, it gets more and more red, kind of fades off. So let's go back to Painter and say, all right, how would we apply this? Okay, so here in Painter, we wanted to say, all right, I want to create something that looks hot. I'm going to do my kind of red here, like I did up top, and I will have it fade out, as the light's intensity fades out. But now I'm going to go over and I'm going to choose, a little bit more orange. Keep the value pretty strong, so have some orange in here, and then go towards yellow and add some yellow in here, and maybe do a brighter little core right in there. Let me do the same with this blue. All right, so I'm going to paint another little section of whatever this is, little meteorites or something, and then I shift the color a little bit more aqua here, and a little more. Fade this out a little more. And this is not an exact science. This is a concept that I kind of want to get across. So you have some sort of icy flame, laser type thing. So notice the difference between these two top ones that look rather flat, and these give a lot more life if you're wanting to have depth of something being hot, something being bright. So this is a concept that's kind of interesting to think about with color temperature. Let me go back to Photoshop here. Now there's one other thing that I've kind of come to realize, doing lighting and working with different people in the industry, is that colors, when you look at this kind of color picker, computer graphics, we tend to think in this, saturation and value. So when you think of a light that's bright, it's kind of at the top, here, and let me choose like a yellow whitish kind of normal light color here, not bright pink. But all right, so you have a bright light and you have a dark light. The problem with this is, as things get darker, they kind of get muddy, you know, because the way the color schemes in the kind of computer work, you know, it's adding value for brightness. Or what happens in the real world is more on a diagonal sense of, as lights get darker, they saturate, or as surfaces, as light falls off, you tend to get more saturation, and as lights get brighter, you tend to lose saturation. So let's take some photo examples and see if we can prove this point. Okay, so actually let me open this back up. So here we go. It follows the color temperature and saturation. Okay, so it's pretty saturated, but as we get darker and darker here, yeah, I mean the colors are actually shifting. Let's try this red. So this red, notice it's a little bit less saturated at the brightest point, and as it starts to lose value, it's going more and more kind of saturated. As I get darker and darker, it's moving closer and closer to the saturated side. Let's check out the blue and see if it does the same thing. Okay, so it's medium saturation. And now as it gets darker and darker, it's getting a little bit more saturated here. It's a little hard to tell. There's some values of reflections and stuff that kind of fade off. But you get the general idea. It's following color temperature and following that kind of, as it gets darker, it gets a little bit more saturated. Let's look at another example. Okay, so this is inside of a room, and let's just look at the walls. Okay, so these are walls painted white. So the brightest point, you know, it's way over here. This is probably a better example of seeing as light falls off, it gets darker with more saturation. So this should, according to my theory, as we get to darker spots on the walls, it should go more towards saturated, not just darken in value. Okay, so you know, this is a very diffused light situation. So as I start selecting around the room and finding darker areas here, kind of see we're getting more towards these more saturated, darker, deeper values of orange and yellow here. So can you kind of see how that's kind of following that? As it gets brighter, it gets less saturated on these walls. A whole variety of colors, set of colors in here, but I think you get the general idea of what I'm talking about. So let's look at some more application to this. Okay. All right, so this is a painting that I did of this cave, and I'm gonna add some little crystals and stuff in here. So I'm starting with the deep back part of this cave is kind of purple and dark, and then as I start to paint in some of the get brighter towards the exit of this cave, I'm using the kind of color temperature thing and going more towards aqua, putting darker in the foreground, you know, since we're deep in the cave, and then start painting in some of these little crystal things here, and I want them to be glowing from the inside. So I'm going to make them red, have a little bit of kind of purple glow around them from the red light, and then I'm going to add orange. I'm going to add yellow for the core. You kind of get the idea of what I'm doing here, you know, to go with that kind of color temperature thing. Some little specular highlights, and you get the idea. All right, so something like this, I've followed those same principles for the way I want to colorize, you know, this image, which is a lot better than my kind of old school muddy method, bring something in and just kind of paint underneath grayscale. It's another example of something I painted recently and following that same idea. So looking at actual values here, you know, the hottest part is pretty desaturated and bright, and then as it falls off, getting more orange, and then to reds. You know, even the sky, the brightest points are, you know, saturated, and then as I get darker, you know, it gets even more saturated down in here. All right, so that's the idea of color temperature. Now, so please forgive how absolutely crappy this looks, but this was made as an example. So this was based off of a photo of my son, and this is how I used to think. All right, so there's sunlight coming in kind of from this direction. I understand that, his shirt is yellow, so paint it yellow in the bright parts, and then there's the shadow part, so it's a darker version of yellow, which actually looks kind of green there. And his face, he's, skin tone, he has brown hair. This is how most people think when they're kids and they're doing painting, or even as adults. What if I were to paint it more like this? Okay, so there's a lot more life in that. It's still kind of a ugly painting just because it was done so tremendously quickly. But look at the complexity. So his shirt, when you look at this, you're like, well, he has a yellow shirt. But there's a lot more than yellow in there. There's yellow, there's orange, there's even red. There's a lot of variety of color following this idea of color temperature. Even on his face, there's different values. It's less saturated and goes more towards a pure saturation. Go and study it for yourself in the real world. Study some photos and see. So applying some of the things from the last chapter too, there's bounce light in here. So the light comes down, it hits the yellow of his shirt, picks up the yellow is the only light that bounces, comes up, hits onto his face, kind of the reflections, in his glasses there, but a lot of this bounce light, and even the light onto his shirt itself. Some of the reasons why you have this bright color is because there's light that's reflecting into these areas of a little bit more saturated, a little bit of cool light, mimicking the light from the sky. All right, so that's color temperature. Now I want to talk also about color relativity. So we've probably all seen optical illusions like this, where you're like, oh, these are two different colors. This is more pink, this is a little bit more blue, when actually it's just an optical illusion. It's actually the exact same color all the way across. But it's something that happens with your eye. When you see colors in different situations, you tend to judge the color differently. So it's actually really difficult to remember a color perfectly. So I'm not going to talk a lot about color theory here and this kind of color stuff. But I wanted to show an example while we're on the chapter of color of how your eye can be deceived at certain colors. Okay, so here's a painting. I'm going to follow the same method here of, all right, so I'm going to paint in the walls. Okay, so the lighter colors, or the brighter spots, are less saturated. The darker spots are more saturated. All right, so I'm going to paint these two characters kind of standing at this table, talking to each other. All right, and there's going to be some bounce light on them. And then I'm going to paint in this kind of cool light from the top, like shining back down onto them. A little more details in the background here. I pre-recorded painting this, so kind of talking over top to prove certain points. All right, so let's take a look at this final image here. Okay, so look at the values here in the actual colors. Now this is kind of a cool thing. All right, so everything stays in this warm palette. Sometimes you want to do paintings that stay all in the same general palette. All right, so we got the bounce light, we've got all this different light. All right, so the thing I want to bring out here is, look at this color. So our eyes say that's like a purple kind of blue color, but it's actually in the red, kind of in the red tones here, all the way red, and it's just a less saturated red. Okay, so here's an interesting thing to do. What if we changed the entire color scheme of this and turned it all on the kind of a blue color scheme? So now, the same sort of rules apply, but I went back in here, and this is actually the exact same color. Let me paint a little swatch of this color here. All right, so that's that actual value. So when I select that value, that's that value. Now if I come back to this guy and select this same select that same value, you'll notice it's exactly the same. So kind of interesting thing to observe. So when you're painting, don't think about colors always from a kind of crayon perspective. I'm going to paint something red, so it's red. I'm going to paint something blue, so it's blue. Grass is green, the sky is blue. Not always. Actually, a lot of times the light, or most of the time, the light is really what you're painting. And the light can affect different colors in different ways, and your eye can perceive different colors in different ways. So this is a good way to think about color. I'm going to show one other thing just to prove that your eye has this thing called persistence of vision. So when you watch animation, or you watch a movie, your eye allows colors to kind of seep in and kind of be deceived in there. And this is just kind of a fun thing to look at. So focus your eyes on this little dot right here in the center for several seconds while I talk. So what's happening right now, if you keep your eye focused right there, is the light is sort of burning into your retinas. And this inverted color, when you look away, don't look away yet, but the color will kind of stay there. All right, you ready? Stay looking at this point. I'm going to change this. Okay, keep looking at that point. Kind of looks like the image is colored. Now move your eyes around. You realize you're looking at a black and white image. It's amazing the things that your eyes will do concerning color. So there's a lot that goes on inside your own head. I didn't really have to put this on here. I just thought it was a fun thing to kind of put in there because it's kind of cool. All right, so remember, color temperature, it can affect a lot of different things. Let's go on to the next chapter and talk some more about things, and as we go, we'll apply these concepts even more.